Constants are not just an obnoxious version of final variables that will haunt you in your sleep with all of the errors associated with them. Compile time constants are actually a nice way to improve the performance of your app by not instantiating the same objects over and over multiple times, and additionally, so to say, pre-instantiating objects at compile time. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, you are finally going to learn about what actually constants are, what are constant expressions, constant constructors and constant factories, what's up with canonical instances and all of that. But first we are going to tackle an age-old question, and that is, should you use const or final for your variables, and what's actually the difference in between them. And if you want to follow along with this tutorial at your own pace, be sure to check out the written version from the link in the description on resocoder.com, because sometimes it's nice to watch a video tutorial, but a written article where you can go over the text multiple times is also good to have. So let's go. Constant or final. It seemingly doesn't matter if you have a constant variable or a final variable, because if you look at these two things from the perspective of not being able to reassign the variable later on, really constant and final are the same thing. So let's try const. My const number is equal to 5, and then we are also going to have final. My final number, and it's also equal to 5. And now when we try to reassign my const number to be 42 and my final number to be also 42, it just doesn't work. And we have constant variables can be assigned a value, and final says basically the same thing. So in this area, not being able to reassign a variable, constant and final do the same thing. And also, final is also more suited for more occasions, while constants can only be used for top level, static, or local variables. So this is a local variable, right? But when we create a class, let's go above the run function. So class, my class, and over here we can create final integer, my final field, right? But when we try to create the same thing with constants, my constant field, and we of course will need to populate the constructor, well, you can see that constant says only static fields can be declared as const. So we cannot have an instance field being const, but it needs to be static. And now it works. Of course, we need to also assign it a value, so 5, and now we're talking, but when it's an instance field, that just cannot happen. Just to avoid the process of taxing decision making, well, whenever you want to create a variable, you will just probably choose final, because you don't have to think about these edge cases of not being able to have a constant field inside a class. And also typing out the constant keyword sometimes is just a pain and you don't know why you should do that. Well, in this tutorial, you are finally going to learn why constants are beneficial, and you are going to be typing these 5 letters const like crazy every time you can, because constants are really helpful performance-wise for your apps. But before talking about performance improvements with canonical instances, let's first go over the built-in constants in Dart. Every Dart type which has a literal is a constant, and that makes sense. Because what is a constant? Well, that's something that is already compiled into the code as a value. So if I clear this up and I write something like 1, 2, 3, well, this is a constant. This is just baked into the code when it compiles. The same goes for strings. 1, 2, 3 as a string is also a constant, or for example, hello world. this is a constant. And only constants can be put into constant variables. And in addition to just integers, doubles, and strings, Dart also supports constants for lists, maps, and sets like this. These are all constants and they can be put into constant variables. But in addition to putting constants into const variables, you can also put them into finals, which you are probably used to, right? You do this all the time in Flutter. You put some string into a final variable or even into a mutable variable var, which can also be said like string. This is the same thing, mutable variable. So why can we even put constants into non-constant variables, for example, finals? And what's the difference between final and const in this case? While we as programmers may not see any difference whatsoever whether we choose final or const to be the prefix for the variable, the compiler sees a huge difference. Let's create two identical variables. So this will be const variable, and above it we are going to have final variable, and they hold the same value, hello world. The only difference in between these two is that one is final and one is constant. So how does the compiler see it? Remember how I said that constants are baked into the code? They are not evaluated at runtime, but rather the whole value is just stored here on compile time. The difference between these two variables then is that the first final variable for the compiler, only this is baked in at compile time. Only this hello world after the equal sign is here at compile time. And this final variable will be assigned this pre-compiled value at runtime. All right, so this hello world will go into the final variable at runtime. The difference between the const variable is then the fact that for constant variables, this hello world will be assigned to this const variable at compile time. And you may think that this is just completely stupid. Why should I care about something being assigned only at runtime or having truly the whole variable being compile time constant? Like, what kind of a difference can it make? It turns out it can make a huge difference. That's because constant variables can be used to populate other constant variables or other places in constructors which require constants to be passed in. So let's try it on a very simple example. So what we can do now is create const. This will not be working because we cannot assign final variable to a constant. Whenever we try to do something like this, assigning finals or vars to const variables, we get an error saying that const variables must be initialized with a constant value. But if we copy the line below, and this will be working, we can assign const variables to other const variables without an issue. And of course, you probably just don't assign a bunch of constant variables all over the place. Instead, you may use constant constructors because of the benefits that they provide with canonical instances, and that's what we are going to touch upon next. You surely know about classes in Flutter which have const constructors. For example, whenever you want to create a padding, and I'm not currently in Flutter so I cannot show you very well, but you have a padding class, and this padding takes edge insets, something like that. I hope my knowledge is correct. And you want to specify edge insets dot all, and from all the sides you want to have 8 logical pixels of spacing. So this is some Flutter pseudocode. And now you probably know that you have a bunch of places, maybe even hundreds of places when you have a big app where you have this kind of code. Edge insets is edge insets all 8. When you have this 100 times in your app, written like this without using the const keyword, what's going to happen is that you are going to clutter up the memory of your app with 100 individual instances of edge insets. However, because edge insets supplies constant constructors or factories, you can specify const before it. And what this is going to do is that those 100 times that you invoke this constructor are not going to instantiate 100 different instances. Instead, it's going to instantiate just one so-called canonical instance, and then all of those other edge insets with the spacing of being 8 from all sides are going to just reuse the same canonical instance. So you went from memory being clogged up by 100 individual objects to only one object being in memory really, and then that single object is reused 100 times. So this is the huge benefit of constant constructors, and of course you can even create your own classes which have constant constructors or factories, much like the edge insets class does. So let's create one right now. We're gonna create my constant class, so class my const class, and inside it we just want to have final fields, because remember, fields cannot be constant. You always have to have final fields, and classes with constant constructors absolutely must have final fields because they have to be immutable once the class is instantiated. So this will be, for example, int field1, and then we're going to have final list of strings field2. And let's just create a constructor for final fields. And now to make our class capable of being a constant, we need to put the const keyword before the constructor. And now let's try to instantiate our constant class. So we're going to remove the bottom lines, and actually let's make these values to being integers, something like this. And now we want to instantiate our constant class. So we're gonna put it inside a constant variable, for example, x, and we wanna make it equal to my const class and pass in the const variable for the first field and some other constant, some list of strings, hello there, as the second constructor parameter. And now we can get back to why it's actually very useful to create constant variables. And that's because you, of course, cannot pass the final variable into the first parameter of our myConst class instance. When you want to pass a final variable to the constructor, which is constant, it says you cannot use finals, you have to use constants basically. So until now everything is nice and dandy. We have just constant capable fields because integer can be a constant, list can be a constant, so everything works out just fine. However, what happens when you want to have a class with a constant constructor which does not hold only fields capable of being constants? For example, what if you want to have a class which holds a future, and a future can definitely not be a constant. So let's just copy this class. We're gonna create, this will be my wannabe const class, and it will have just one field, and it will be of type future, which will hold integer. And now we of course need to populate this with a constructor for final fields. And let's make this into a constant constructor. And the thing is, you can have a constant constructor even though it holds a field which just cannot be a constant at all. Let's look into the definition of future. It's an abstract class, but it has some factories, but those factories are not constant. They are just simple factories without the const prefix in front of them. So you cannot have a constant future, which kind of makes sense because futures always change in their value. So how come that we can have a non-constant capable field here inside a class with a constant constructor? Why does Dart allow us to do something like this? Well, that's because you create constant classes only when you say so. You can invoke a constant constructor even when you create multiple new instances with it. Even what we have now inside the run function where we instantiate my const class, when I hover over it, you can see that there is a const keyword in the tooltip. But when I change the type of the variable to which this instance is assigned from const to, for example, final or var, look what happens with the prefix. It changed to new. Before it was const, now it's new. This is called the instantiation context, and there can be either constant context or this regular context, which just prefixes instantiations of classes with new. And of course, you can write the new yourself, but it's kind of redundant. And in the same way, you can write const yourself. So what does this mean for our wannabe const class instantiation? Well, we can put it inside finals with implicit new, and it will be equal to my wannabe const class, and let's pass in future dot value and 1, 2, 3 or 4 or 3, it doesn't really matter. So this invokes the regular implicit new constructor. I think you use this on a daily basis. You never basically specify new yourself because it's very redundant. You can also have explicit new, just for the sake of demonstration. And in the same way, you can have constants being instantiated with implicit const or explicit const. So the two line groups are really doing the same thing. Just one is implicit, one is explicit. But as you can see with our wannabe const class, we have a problem when we try to instantiate it as a constant, because future.value is not a constant ever. And it doesn't really matter if we write out const keyword explicitly or we leave it up to the Dart compiler to figure out that we want to have a constant here. We always get an error that future is not a constant. So let's delete the my wannabe const class, which really cannot even be a constant, and let's go back to our class which can actually be a constant, and let's just make it have one int field for the sake of simplicity. And as you know, you can have implicit constants and also explicit constants like this. But why would you even want to do that? With the new keyword, you probably never specified manually since Dart 2.0 came out, because it's very just redundant. But is there a place for specifying const keyword yourself manually? Of course there is. You're going to specify it manually whenever you want to store a constant canonical instance inside a non-constant variable. So for example, when you do something like final my variable, which is just a regular variable, now when you want to invoke the constant constructor, you have to specify it manually, because if you don't, you delete this const keyword which you have specified prior to the class instantiation. Now the Dart compiler will figure out that, oh, I should probably instantiate a new instance and not a constant instance, and reuse the canonical instances which I already have stored somewhere. So this tutorial has hopefully demystified the meaning of const constructors and Dart constants in general. So try using the const keyword whenever possible, and you will bring small performance improvements into your apps every single time you use that const keyword. And you know how it goes with small improvements. Well, they add up. And to go through this tutorial at your own pace once again and to get all of the code, check out the written tutorial available from the link in the description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. And if this video helped you, give it a like and also share it with other developers who will surely find it beneficial too. If you have anything to say, leave a comment, and see you in the next video.